Welcome to Griffin's CEA Solution Spotlights. Our Controlled Environment Ag team uses these videos to demonstrate how we work with our suppliers to solve common needs and concerns from our growers and cultivators. Today we will be talking about EC and PPM, what these terms mean, why they are important to understand, and why they can be confusing. We have Jess Robinson and Erica Hernandez from Griffin's CEA team, along with Blue Lab's Darren Gilbert and J.R. Peters' Dan Gillespie. Jess, how about you get us started?
Yeah. Okay, well, thanks for joining us today, you guys. We have a lot of growers who often mix up or misunderstand the terms PPM and EC when talking about fertilizer. Darren, could you tell us a little about what EC is exactly and how growers can measure it in their fertilizer solution?
Yeah, absolutely. Thanks, Jess. Appreciate that. EC stands for electroconductivity, which really is determining how much fertilizer salt or other salts are dissolved in your nutrient solution. It lets you know what is going to be available in the nutrients to your plants. Like you said, there's a lot of misconception between PPM and EC, and it's really just a mathematical equation. But either one doesn't necessarily tell you the total indicating content of what fertilizer is in there. So it's not going to tell you how much you have in nitrates or other fertilizer elements that are going to be in there. It's just going to give you an overall view, a sort of a snapshot view of the total salts that are in there. And what substances can be measured is either liquid, or newly developed are devices that can actually measure in a substrate, not just in a liquid. Initially, there's some devices like the truncheon meter that allow you to put this right into your nutrient solution, and it's going to light up on here and tell you what your concentration is. This device happens to read EC and PPM, so it can be utilized either. But we also have a device called the pulse meter that can be utilized in any substrate. So it can do liquid or it can do soil. It can be used out in the field, where you can put this in and it'll tell you your moisture content as well as your EC level and your temperature of that substrate, and it can record right to a phone. So you can have various types of substrates. The problem with EC is that most people will take the time, or not in most cases, take the time to actually mix up a slurry. A slurry consists of using distilled water, and typically it's a 3-to-1 ratio, 3 parts of distilled water to 1 part of your substrate. You mix it up, it's got to sit for about 20 minutes, then you come back and you take a device like this and you put it in and get your reading. Well, people don't want to do it because it's time consuming, it's cumbersome. If you get called away, then it's no longer good. You got to start it all over. And the biggest limitations to EC is that we can't see a breakdown of those nutrients, like I just mentioned. All you're seeing is that overall global picture. So, if you really want, you can send it out to a county office, or you can send it to a local college or university. The problem is when you get that results back, it's now going to be a week to 10 days late. So you're looking at history, what it was, not what you're looking at currently. And that's where devices that are out there in the field, like Blue Lab makes, that make it so you can see it and make your adjustments currently. But thank you. I appreciate the opportunity to talk about our products.
Thank you, Darren. That was a great explanation. I think it's going to be super helpful. I know a lot of growers talk about EC on a daily basis, but what about PPM? Dan, how does this relate to fertilizer programs?
Yeah, thanks, Jess. So PPM stands for parts per million. And before we begin, I think it's important to note the difference between parts per million as it relates to milligrams per liter or milligrams per kilogram, but really how it relates to concentration, but the difference between parts per million as it relates to concentration and the way parts per million as it relates to EC and measuring the strength of a solution. So as Darren just discussed, parts per million as it relates to EC is a conversion from EC that's going to be obtained by an EC or PPM meter. This is used to measure the strength of a solution or provide an indication of the salt levels in a solution. Alternatively, and what I will be focusing my discussion on, is parts per million as it relates to the concentration of a particular element or a plant nutrient. So this is a way of expressing very dilute concentrations of substances. It may be used to describe the concentration of an individual element or nutrient in a water sample, a soil sample, media sample, or plant tissue sample. And 1 part per million is going to be equivalent to either 1 milligram per liter or 1 milligram per kilogram. So in the case of water or solution, it would be 1 milligram per liter. In the case of soil, media, or plant tissue, it would be 1 milligram per kilogram. But the important thing to kind of keep in mind here is whereas PPM and EC as it relates to measuring the strength of a solution will tell you the salt level, PPM as it relates to concentration will tell you the individual elemental concentration. So how much nitrogen may be in your source water or in a nutrient solution. And this is going to be used to measure the elemental concentration of water, so source water, solution, nutrient solutions, grow media, soil, or plant tissue. And really what we use it for in the horticulture industry is it really helps us or provides a good indication of the nutritional status or what's in a solution or what's in water. And we can use this information not only to determine crops' nutrition requirements, to make fertilizer recommendations, to develop fertilizer application rates, but we can also use this information to diagnose issues and prescribe solutions as well. One thing I do want to note is this type of analysis and determining the individual elemental PPM or individual elemental concentration of a particular sample, it's almost always going to require a lab analysis. There are starting to develop certain instruments where you can do this in-house, but I'm not sure how accurate that is. So most people are going to be doing this type of analysis and getting this type of data through a commercial analytical laboratory. But I mentioned that we use this in the horticulture industry to develop fertilizer formulas, provide fertilizer recommendations, and to diagnose and solve issues. But we also use parts per million in terms of discussing application rates when it comes to fertilizers. So it's very typical in the horticulture industry to discuss fertilizer application rates in terms of nitrogen parts per million or nitrogen PPM. So you may hear a grower say, I feed my crop at 200 parts per million nitrogen. So what do they mean there? So let's discuss that. So we know that nitrogen is used by plants in very, very large amounts, and nitrogen can really dictate plant growth and plant morphology. So more than any other nutrient, it's critical to ensure we're providing the plant the proper amount of nitrogen at each growth stage. And because of this, almost all premix fertilizers are going to be formulated by starting with nitrogen in mind, and then ensuring that all the other macro and micronutrients are in the correct balance and ratio according to the nitrogen content of a particular fertilizer. So a grower may say, I'm feeding at 200 parts per million nitrogen using a 15-5-20 fertilizer. So what that means is they're applying 200 parts per million nitrogen. Their mixing rate is a mixing rate to achieve that level of nitrogen. And then all the other macro and micronutrients should be balanced and formulated correctly within that premix fertilizer. So nitrogen parts per million, it's a common way to discuss application and fertilizer rates within the horticultural industry. So at J.R. Peters and at Jack's Nutrients, we know that the nutritional demands of a crop are going to change as we transition a crop into different growth stages. So we have worked not only to develop species-specific nutrient concentration targets based on parts per million, but we also develop these targets for each specific growth stage of a crop. So using these species-specific and growth stage-specific targets or concentrations, which are going to be measured in parts per million, as our guideline, we can start to calculate and select Jack's Nutrients fertilizer formulas that will hit these nutrient concentration targets at each particular growth stage. So, for example, in vegetative growth, our goal here is really, in most cases, we want to push vigorous leaf and shoot production. So we're typically, providing high concentrations or high nitrogen parts per millions in vegetative growth. Alternatively, the goal of reproductive growth or flower growth is typically going to be to push heavy and high quality flower and fruit production. These fertilizers or these nutrient solutions are going to be characterized by higher concentrations or higher parts per millions of phosphorus and potassium. So I think the main takeaway here that I really want to drive home is that it's critical to ensure or to understand that even if our target EC is being hit, that does not necessarily mean our individual nutrient concentrations in a solution are being maintained. So while it's important to monitor and keep an eye on our EC, and that can give us an idea of what's in that solution, it's really also important to ensure that the individual elemental and nutrient concentrations within a solution are being achieved as well. And I believe Erica will kind of really dive into that a little bit here.
Excellent. Thanks, Dan. More great information there. Erica, can you tell us a little bit about how our technical team, Griffin's technical team, GTS Pro, can bring this all together for a grower?
Yeah, Jess, thanks. And thank you, Dan and Darren, for the great information we started with there. Yeah, GTS Pro works with our customers to really help them understand and implement fertilizer programs that are appropriate for their specific needs. So before we even get to the EC and the parts per million considerations at all, what we start with is a water test, because we need to know what that beginning EC is, if there's any salts that might be contained in the water. Before we even add fertilizers, we need to know what that beginning water looks like, because that beginning EC, those beginning parts per million of whatever salts are there, can affect your fertilizer program. So it's a very important step. But once we get past that, what we do is we design fertilizer programs with the parts per million nitrogen in mind as our target. Dan talked a lot about individual nutrients being our targets we need to hit, and that is definitely the case. We want to look at, are we providing enough nitrogen, phosphorus, and potassium per stage, per growth stage? And we want to be able to tell our growers that they're providing, they're mixing up their fertilizers in an appropriate manner to hit those targets. So let's take a look at this graphic here that will go over an example of spacing out our EC and our parts per million and how that relates to our different fertilizers. You can see how, as Dan mentioned, for different growth stages, we do target different parts per million nitrogen. And this graphic is really going to show you how that parts per million and EC really interact throughout a production cycle. So what's important to remember, as Dan started to get at, is that our target that we're looking at is the target parts per million nitrogen. And when we look at our EC, it's not necessarily that the EC is our target that we're trying to hit. The EC is the result of hitting those parts per million nitrogen targets. So when we design these programs, we design them with our nutrition targets in mind, starting from there. And then we can tell our growers what EC to expect when they're hitting those targets. So having that information on hand is a great way for our growers to make sure that they're on track by having qualities that they can measure, EC, that will tell them that they are applying the nutrition that they need, because we've made those calculations for them. We know that these fertilizers are applying this amount parts per million nitrogen, phosphorus, potassium, calcium, everything that your plant needs. And if they're measuring their EC where we expect them to be, then we know that they're on track. So really, what growers need to remember is that with these fertilizer programs that they work with GTS Pro, with J.R. Peters, we've figured out those parts per million. We know what your EC should look like. It might not be saying that, oh, you need to feed it 2.5 or 3 EC, but we will tell you that, yes, you can expect this EC at this point. So that's really the strength and the connection between parts per million and EC that our growers need to be aware of.
Awesome. Okay, thank you for everyone for being here, and that was amazing info today. If anybody has more questions, we're going to display the GTS Pro contact, J.R. Peters and Blue Lab as well. And if anybody that's not a Griffin, or if you don't have a Griffin account already, you can feel free to call in, and any of our customer service reps can get you set up. 800-888-0054, extension 89199. And thanks again, you guys.
Yep, thank you, Jess.
Thanks,
you.
Jess.